part of that project. Oh, come on. Shoot. So the STEPS project idea was to basically reinvent personal computing. And so let's make a sort of understandable representation of the entire personal computing environment and in a very concise way. When like Mac OS or Windows are written in hundreds of millions of lines of code, why can't we write that stuff much more simply? And it sounds from 200 or 400 millions of lines of code going to 20,000 lines of code sounds ambitious. But we had a good example, which was Squeak Smalltalk, and at one version that was roughly 400,000 lines of code. That includes its own interpreter, of course, and its own graphical system, network system, and like memory management and user programming system. And everything included was like 400,000 lines of code. So from that, making something like 20,000 lines of code isn't that crazy. We just need to do 20 times reduction. And the approach we decided to take was create many domain-specific languages and describe different parts of the personal computing system in these different languages. We invent a new language suitable for that part, and we write stuff in there. And that means we sort of need to build like ecosystem or big guy from different parts. And some parts are execution engine and graphic systems, which Bart, I think, showed at Edinburgh like a few years ago at ESUG. And some application framework and in these apps, yeah, we want to write this stuff, but we want to connect these little parts by meta language, which is a language to make more languages. And if we zap the power into this guy may wake up and do something interesting. So as I said, yeah, we have a very nice graphic system, which Bart showed a few years ago here, and we have a nice have a few nice meta languages like O-Meta and Ian's Cola stuff. So, but here, I'd like to concentrate on the application framework and these apps. And it's not just we just don't want to write the simplest, dumbest kind of framework. We still want to have a nice interactive nature and want to have a nice uniform graphical, uniform object model. And basically, yeah, we at least want to do the stuff we could do in eToys, for example, really interactively build stuff. But also the downside of eToys was that it didn't have a nice, clean semantics on time. And we looked at many time-aware computation models, starting from John McCarthy's situation calculus and stuff. But nowadays, functional reactive programming is a vogue. And I looked at it, and it seems to be fairly clean. So I decided to take it and implement our stuff. And FRP, or functional reactive programming, sounds very complicated, but it isn't. So it's just like Microsoft Excel, basically. So this is my graphical object. And what you can do is to get a kind of inspector here. And so it is like Excel. So I can define a new cell, for example, say my object field A is a value 100, right? And I can probably say B is like, I don't know, A plus 1. So because B, the lower pane shows the definition and the upper pane shows the upper pane shows the definition and lower pane shows the current value. And maybe I can go into A and change the definition to something else. And yeah, so it changes. So it's like Excel, nothing more. And maybe I can say C is like A times B or something like that. So yeah, what big deal? What's the big deal? But one thing FRP lets you is to have some cell that depends on time. So if I say timer E, like 1000, so this one now your Excel cell is updating itself for every 1000 milliseconds. And if you look at other values, yeah, the other cells are updating. Also, okay, yeah, I can use time in my system, but yeah, it's not still a big deal. But one thing I can also do is, let's say, undefined. There are some predefined names for my object. And if I define a field name, like a bottom down, now I can, maybe I should get rid of the halo. I get a new value into my cell when I click on it. And notice I have a field called position, and that changes when I do it. Also, that's an indication that maybe I can write some new spreadsheet cells called my mover, and this, maybe I can say bottom down position. And yeah, this is my cell definition. And now I click it, it moves to the center. So it's basically these variables are connected to each other via dependency, and the system tries to resolve everything. And basically, my graphical objects, all fields are, these are reactive variables. And okay, so it seems to be working at this point. So let's build like entire system in this way. And so yeah, this is another kind of object, and maybe you can add more, add a new box, and maybe I can edit gradient and stuff. I'm not going to do all steps, but there's a sort of pre-made cake in the oven. So if you do this interactive development, like spend hours, you get this kind of sort of nice looking widget. And these are like buttons and stuff. So if you really do spend time, you can build like an entire like Microsoft like document system in this way. So you can do some stuff like, so let's say I want to edit this gradient, and I can change like a gradient here, for example, and stuff. But if you do this, yeah, what's going to happen is, there's a little shortcut for me, but what happens is that you're going to get this situation where you edit your document editor in your document editor. And here you can do, so these are, including myself, this is my group who did stuff. And maybe, yeah, okay, so maybe let's take over the entire screen with the new version I'm making and stuff. So we did this, and basically with like 10,000 lines of code, we wrote this UI part. And let me just show one little example I like to show. And this is a document editor, so you want to make many kinds of documents, including the active essay kind that Alan was talking yesterday. And yeah, I'm not going to go into detail, but what you can do is, because the reactive thing is like a spreadsheet, yeah, why don't we just organize these cells into a 2D grid? And there are formulas stating that each of these guys are connected. Oh, no, like I do this, and also, and this person, imaginary girl, 14 years old girl, would make like each of like objects by these rectangles and connect each rows into these little boxes. And once she says, timer is like 20, oh, yeah. Then you go to the full screen again, maybe, and do it. So my arm moves this way. So what it's doing is that each of these 5 arms are just rotating on its own speed. So it's basically, if you look at these arms, the y coordinate, it's basically doing the sine curves, but with a different amplitude and different angular speed. And by embedding each other, I'm just adding them. So that means I'm basically making a Fourier series for the sawtooth wave. So if you look at the y coordinate of the tip of all arms, so it goes down, and people's favorite part, it's a straight up part and going down, and so she can do this kind of simulation in this environment. And so this is really a tiny part of the project. And what's going to happen here is, so now I'm going to talk about totally different things. And there are a few sort of old people, just 30 seconds, sorry. And what we have is, at the viewpoint, is a bunch of videotapes from 80s and 70s. And these are like hundreds of tapes, VHS tapes, beta tapes, like U-matic tapes, and so it's deteriorating. So I decided to digitize all these tapes at my spare time, and I can show some of these Star Trek bivalent projects recording like ACM, history of personal workstations talks by different people, and we have these tapes. So I digitized these. I'm digitizing these, and just started uploading some of these, only a few of these, to my YouTube channel, like this. So there are many tapes we cannot make public, but some of the tapes I can make public. I'm slowly adding new things. So please check this channel, and hopefully you enjoy it. And that's my talk.
So I have a question. Did you digitize the tapes with your system, or the tapes were digitized with your system or with third-party software? The tapes that you digitized, you used your system, your
All right. Neil's next. If you could later come over for the microphone, then that's great. We good to go?
Yeah. Hello, everybody. I am Sergio Mas. I'm going to show you a small project which consists of using Google Maps for Rosal. Currently, Rosal has some maps builders which allows it to visualize data over maps, like this one, for example. I'm sorry, this is slow. Okay. Here we're visualizing earthquakes, for example. So Rosal has builders for that. If we use a Google map, it would look like this. But what is the advantage of that? In this case, the advantage is actually not much. But Rosal is restricted by the SVGs it uses for drawing the maps. So if we want to draw data over maps of smaller areas, we may not have the SVG. So the project would be useful for that. For example, just a small amount of, oh, damn, sorry. Yeah, the battery is wrong. Damn. Yeah. I'm sorry. I thought it would be enough. Okay, I can talk meanwhile how it is made. Well, the project make uses of the Google Maps geocoding API for geocoding addresses or locations and translating them into geographic coordinates, and it makes uses of the static maps API for getting the maps. So what it does is just get the map and make a Russell element with the map, and then we have a builder for building maps with the Google image. And the project depends on Neo.json for managing the JSON data, and it depends on Sync for querying the server. No. No. Just once. Okay. So we were in this example, I think. Oh, we're not connected. Yeah. So in this case, we're using the builder. Just some simple data in a city that we define as a string. We just put the name of it, another one, and we can also use the coordinates. We can change the type of the map. We can actually use all of the facilities that the API provides. The project includes a direct mapping of the static maps API, and also it has the builder over it. Here we have a satellite map. We can also have markers, for example. This is the subway network of Santiago de Chile, and here we have some markers for each of the metro stations. That's about it. You can change the icons of the markers. Using any SVG image. For example, here we're using a some SVGs for marking hospitals or universities. And I think I'm running out of time, so but that's about it. Any questions?
And that will be 4 minutes for questions.
Does your interface also has some possibility, does it add some artifacts from Google? So saying, for instance, if you have a map of a country that you can click on the cities or something like that?
Click on city.
Or do you have to add all interesting points, so to say, yourself?
Yeah, I would have to add them because I'm using the static maps API, which only gives me the map. That's
Okay.
I can't use the tiles, for example, because there's a terms of service restriction. So I can't use like the JavaScript API.
Okay, thank you.
More
And
questions?
yeah, another one. These icon symbols, are they rendered by Google or do you place them your own?
Well, I didn't.
The icons, the markers, are they rendered by Google into your map or
No.
do you place them your own?
No, I placed them.
So
They're
you have to
SVG
know exactly where in your JPEG or whatever you get from Google the position is for your marker.
I have to give the position.
So do you send your private data to Google to have a marker on the map or
No.
no? Okay.
No. Yeah, you have to. I sent the center of the map and the size of it. That's all.